So today we're going to do a couple of demos. We're going to provide a tray-to-tray demo using our 8th generation, or excuse me, our 8th socket 10th generation sites. I think I skipped that part. One of the innovations was the double the socket density. You know, we for many years had a flagship in our 4000 series machine, and we shipped hundreds of those machines all over the world. Fantastic product. But frankly, the technology in that did have some limitations in that it was an older machine and the cost to develop and to ship those were substantial. So what we've done, a 48 socket machine that, you know, may have been twice the cost of the BPM310 now gives you all that same value in this platform, the smaller platform. So you can have up to 6 programming sites and 48 sockets. In fact, most of the programmers, even in the 4000 series that we've shipped over the years, have been less than the full complement of 10 or then later 12 sites. So again, you can do the math simply to see that the cost to purchase one of these machines is so much more competitive. So again, making device programming easy. I think, Charlie, let's start off with a simple maybe tray-to-tray job. How would that be?
Okay, sure.
I'll tell you what. Instead of that, let's do what a changeover looks like.
Right.
What would that be with one of our 10th generation sites?
Okay, so here we are inside the BPM310. You'll see here there's a tray stacker. Over here is a tape loader. We have our Y-beam here. There's 4 programming sites. These are all 10th gen. The sites here, number 1 and 2, they have our 8 gang socket cards. It's a single card with 8 sockets. Over here, we're just doing a demonstration showing that you can have your old 8th and 9th gen FEE4 cards also. You can run those on these sites. Of course, you can't run all this on one job, but we'll only be using these 2 sites for our demonstration purposes. Now, we'll say that the stepper motors for the 9th and the 8th gen sites, they had about 30 pounds of force to pull down 4 sockets. The 10th gen sites have much stronger, much larger, and more robust stepper motors that can easily pull down the 8 sockets. They pull about 100 pounds of force. So anyway, let's say we finished a job. We're going to start a new job. You simply remove the pressure plates. And we have this handy little ESD safe plastic tool that you can pop out your socket cards. And then you change over to a new job, whether it be the 8 gang or the FEE4s.
And here's another style, Charlie, that I borrowed.
Oh, yes.
Yeah, so this is a gang 2. And so in the instance where the socket fits accordingly, we could deliver 4 gang 2 adapters that would fit on the 10th generation site as well. So there's some variability, kind of like we've seen over the years, available, you know, on the 9th generation and 8th generation.
Yes, excellent, Colin. Thank you.
And the other note is, you know, like our previous designs, the one you have in your hand is a mechanical compression socket. So we'll talk a little bit more about fault tolerance in a few minutes and discussing what that means to 10th generation, since it shares a common PCB in some cases.
Very good. Okay, so we just install the socket card onto the programming site. We install our pressure plates. Note that the pressure plates are quite a bit thicker than the old pressure plates. That's so that they do not flex. Good. All right, while we're in here, I'd like to point out the machine has a downward looking camera, which is an aid in teaching. What it will do is when you're teaching, it will present the image on screen and superimpose a crosshair so that you can locate your device for teaching locations.
And Charlie, we have the ionizer as well.
Yes. Would you like to talk about that real quick?
Yeah, the ionizer, certainly in environments that we deal with, ESD safety is very important. And so the integrated dual AC self-regulating ionizer is an option that most customers decide to go with. It's really an important feature, especially with the small chip scale packages.
That's right. We've had issues in the past where the really small, lightweight devices, the arms of the socket that hold the device down, when the arm comes up, the devices can stick a little bit. And so by directing flows of ionized air down into the sockets, it minimizes that effect. Okay, and this is a nice addition if you're dealing with sensitive and very small devices. At this time, I'm going to go ahead and select a short little job to run tray stacker to tray stacker. Open my workflow here.
And while you're doing that, Charlie, again, the machine today, as you can see, is configured with our tray stacker TS1500. This is something we designed and we manufacture here in our Houston facility. And we also have a tape output unit. It's a VTech unit made in the USA. We've aligned with these guys for well over 20 years, and it's been a very robust platform.
Yes, it has.
Capable of supporting tape widths of 8mm up to 56mm.
Okay. So you see we presented the first tray now, and system's going to do a continuity test to make sure there's no devices when we start the job. So the way we actually operate is we will place one device into the socket, make sure it's successfully programmed before we start in concurrent mode running full speed. And the reason is that we want to make sure that the job selected is correct for the device. That way you don't end up with a lot of rejected devices at the beginning of the job.
Yeah. So we mentioned fault tolerant architecture earlier, and please add your comments.
Sure.
But from my standpoint, it means our sites operate independently. So
they do.
And then the sockets themselves
Indeed, they do. Yes.
Operated independently. So
sure.
You mentioned that you have compression sockets on the example board that you're running. And so what happens, Charlie, in a case where they're running the job and the operator notices the yield is low on one of the sockets, what would be some of the actions?
Sure. So yeah, what they can do is in BPWin, just click on the socket, right click, and disable the socket for the remainder of the job. Okay. And they can also do that for the whole site.
And if they wanted to set a threshold for the number of rejects per
That's right.
socket?
There's an option inside BPWin that can set a maximum number of failures on any socket, and it will stop using that socket for the remainder of the job when that limit is reached.
And we also have an odometer on each of the sockets too, right? So you
with socket module counter. That's right.
So that allows customers to become familiar with the replacement rates.
That's right.
And then they preset that and do either a cleaning routine first of all, and then
socket maintenance routine interval is what we call that.
Okay.
Yes.
Very good.
Okay, so that finishes that job. Sockets have closed. Make sure that there's no devices left in the socket. And that tray goes to the output. Head goes home, and we will get a job summary report.
Right. And so the job summary report, say a little bit more about that. What's included in the job summary
it's
report?
everything about the job. The BP file name, ABP file name, the handler serial number, the site serial numbers, the time the job started, the date the time job ended, the duration of the job, how many successful, how many failed devices, and it gives you a breakdown of failures by type. And even there's sections on the very bottom of the form that tells you how to mitigate the failures to improve your DPH and yield. So
let's say the customer's data file gets larger and now they're not operating at full throughput. In this case, with the BPM310, let's say 2 programming sites. Would it tell them, hey, add a programming site or add additional sites or sockets?
Absolutely, yes.
Okay, so there's a helpful hint to maximize the production of the machine.
Correct.
A little bit about that I skipped through earlier. This is our second go through today. We'll have another repeat performance this evening, but this programmer, again, compared to say the 4000 series machine, we have a max throughput of over 1,400 devices per hour. And it's safe to say that in a 3 production shift per day routine, you could program up to 4 million devices per year. And I'm working with one of the other managers, and we're for a project now, we quoted a system like this And with 2 programming sites and 8 sockets on each site, they're able to produce over 4 million devices per year. So incredible return on investment, incredible lower cost per device compared to just a few years ago. So something to certainly keep in mind.